In this lesson, we will look at section 5.6, Properties of Linear Relations. In this lesson, you will learn how to identify and represent linear relations in different ways, define rate of change, and we will look at the properties of linear relations. First, a table of values. For a linear relation, a constant change in the independent variable results in a constant change in the dependent variable. So if you're given a question about a table of values and it asks whether that table of values is a relation or not, you have to check to see if the independent and the dependent variables have a constant increase or a constant decrease. The dependent and independent variable doesn't need to have the same increase or decrease, as long as that each variable has its own increase that is constant. So we look at the distance here. Each element in the distance will increase by positive 100, and each element in the cost will increase by positive 20. So since this is happening, it is a linear relation. Next, a set of ordered pairs works in the same manner as a table of values. As long as the independent variable has a constant increase and the dependent variable has a constant increase, it would be a linear relation. And we can see that there the independent is increasing by positive 100 and the dependent is increasing by positive 20. Next, a graph. That might be a little more familiar to you since in grade 9 you covered linear relations and looked at different types of linear graphs. So in order for a graph to be a linear relation, it must be a straight line. Since it is a straight line, that means that the change in the independent and the change in the dependent variable is constant. So every time we go up in the dependent variable, we're increasing the cost by 20, and the distance is changing by positive 100. So therefore, the constant increase in both variables results in a linear relation. Rate of change is the change in one quantity with respect to the change in another quantity. The rate of change can be calculated from a table of values, ordered pairs, or a graph. The rate of change can be expressed as a fraction, as you can see there. All you have to keep in mind, it is the change in the dependent variable, which is your vertical axis on the graph, or in a table of values of your ordered pairs, it would be the second element. And in our case, with the time, the distance, and the cost, we are looking at a dependent variable change of $20. And then we have a change in independent variable, which resulted in a positive 100. And we saw that from the table of values, ordered pairs, and the graph. So once we calculate that, we get a 0.20, so 20 cents per kilometer. We can determine rate of change from an equation as well that represents a linear function. So if we looked at the example, let the cost be C dollars and the distance driven be D kilometers. An equation for this linear function would be C equals 0.20 D plus 60. And every piece of that equation is going to have a meaning and is going to represent something important. So the C is going to represent cost, which is our dependent variable. The rate of change is 0.20. D is the independent variable, and our initial amount is 60. So our important thing to look at here, if we're looking for rate of change, will always be the number that is attached, the coefficient attached to the variable that is independent. So in this case, the 0.20 is the rate of change because it is attached to the independent variable. Linear relations. How can you determine if a linear relation is linear, or determine if a relation is linear or nonlinear? Using a table of values or ordered pairs, check to see if the changes in the independent and dependent variables are constant. Linear relations have graphs that are straight lines, or if you're looking at an equation, The degree of a linear relation must be 1. So if you have an equation that has a squares or a higher exponent, it will not be a linear relation. We can only have an equation similar to the one that's there, y equals 2x plus 1. Constant change in the independent variable represents the horizontal change in the graph. Constant change in the dependent variable represents the vertical change in the graph. This constant change is represented and is known as the rate of change. So, in summary, a linear function has a constant rate of change, and its graph is a non-vertical straight line. The rate of change is positive when the graph goes up to the right. The rate of change is negative when the graph goes down to the right. Linear relations can be represented using a table of values, ordered pairs, a graph, or an equation.